Okay, so today we're doing the deposition of sediment lab. All right, so what we're going to do in this lab is looking at deposition. Remember, weathering is when rocks break in little pieces. Erosion is when those pieces move from one place to another. Deposition is when the particles basically get dumped in a new location. Now, some things that determine how particles settle in water, one of the factors is the size of the particle, which is what we're going to look at today. So we're going to see how the size affects how fast particles settle in water. And then we're going to use that information to predict or make an inference of how long it would take a different sized particle to settle. So what we have is a tube full of water, and we're going to drop 3 different sized particles in there. 3 different sized particles we're going to be dropping is the first one is 2 millimeters in diameter. The second one is 7 millimeters in diameter. And the third one is 12 millimeters in diameter. All right. So with the tube, you're going to drop the particle in there. You're going to start timing when it passes this first piece of tape. You're going to stop timing when it hits the second piece of tape. Now we're going to drop 2 little ones, 2 of the 2 millimeter ones, and then figure out what the average time is for them. 2 of the medium ones and find the average, and then 2 of the big ones and find the average. And then from that, what we're going to do is we're going to calculate how fast or the rate at which those particles are falling down. Now, before we start dropping particles, we need to measure the height of the tube for when we calculate the settling rate later on. Now, it says height of the tube, but what we're actually going to be measuring is just from the one piece of tape to the other piece of tape. So the top of tape to top of tape. Try saying that 5 times fast. Top of tape to top of tape. Anyways, so here's right here. I'm going to measure in centimeters the top of one piece of tape to the top of the other piece of tape. And I do that, and they are 38 centimeters. 38 centimeters is the height of the tube. All right. Next. All right, so over here I have my particles. I'm going to drop my little particle first. And I'm going to drop it in here. Again, I'm going to start there and stop there. All right, so the first one. All right, so I got 2.2 seconds for the first one. Right. Second one. Again, same size particle, just a second trial. .2 also. Now for the intermediate size, the 7 millimeter particles. Reset that. Yeah, drop it in there. Got 1.7 seconds for this one. All right. Got the next one in here. Is 1.6 seconds. And lastly, going to do the biggest particle. .4 seconds. And 1.2 seconds. So what I want to do with it next is I want to calculate the average settling time. So for my smallest one, they both worked out to be exactly the same. So the average of 2.2 and 2.2 is just going to work out to be 2.2. The average of 1.6 and 1.7. So I do 1.6 plus 1.7, hit equals, then divided by 2 gives me the average. So that works out to be, on my calculator, I would get 1.65, but I want to round that to the nearest 10. So that's actually going to round up to 1.7. And the last one here, I'm going to let you do on your own. So I'm not going to do that one for you. So you need to find the average of 1.2 and 1.4. So you add them together, it equals and divide by 2, that gives you the average. All right, next, what we want to do is we want to calculate the settling rate, or the speed at which the particles are falling down. So what we want to do is take the height of the tube and divide it by the average settling time. All right. So the height of the tube was 38, and my average settling time for the small particle was 38 divided by 2.2. This one works out to be 17.3 centimeters per second. All right, for the 7 millimeter one, all right, it height of the tube 38 and travel that in 1.7 seconds. So 38 divided by 1.7. And this works out to be 22.4. And then for the 12 millimeter one, you're going to have to do that one on your own. So it's going to be the height of the tube divided by your average settling time will give you that. The rate is traveling, and you want to round that to the nearest 10. All right. Next. Once you have that done, what you're going to have to do in the lab is make a graph. And what you're going to be graphing in the lab is the particle size on the x-axis. So these numbers right here, what you're going to be graphing on your x-axis. And on the y-axis, it says average settling time. So it's going to be these numbers right here are what you're going to be plotting on the y-axis. So my first one, 2 millimeters, it took on average 2.2 seconds. So I'd go 2 millimeters, 2.2 seconds, somewhere around there. 7 millimeters, the settling time was 1.7 seconds. So 7, 1.7 to be right about there. And then you're going to have to plot the value for the 12, which should be over here someplace. Then after you have your 3 points down, you're going to connect your 3 points with the line. So connect those two, and then wherever the third point is over here, you're going to connect that one as well. Now, once you have that line on the graph, what you can do with that line is you can predict how long it would take other sized particles to settle. So for example, if I wanted to estimate how long it would take a particle that was, say, 6 seconds to settle, or excuse me, if I wanted to figure out how long it would take a particle that was 6 millimeters, if I wanted to find out how long it would take a particle that was 6 millimeters to settle, I could use this graph to do so. All I'd have to do is, there's my graph. If I wanted to look up how long it would take a particle 6 millimeters to settle, I just go up like that, and then go over like this. And then that would tell me how long it would take that particle to settle right there. All right. So once you have your data table done, and once you have your graph made, then you can answer the question, the space in the experiment, and what we've covered on deposition. All right, that's it.